This next question, f of x is x minus 2 over x plus 4, so linear over linear. I've graphed it in Desmos to the right there so that you can see the red graph is the x minus 2 over x plus 4. And we're going to take a look at what's the slope of the tangent at x equal to 3. And I extended this question to also include what's the equation of the blue tangent line there at x equal to 3. And you can see the point of intersection there on the Desmos graph. And here's the equation that I came up with. You might want to pause the video and see if you can try this on your own and see if you get that answer. And then when you return to this video, you can check and see if how it was done in case you didn't get that answer. So let's get started. So we'll recall that the slope of the tangent is just equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, in this particular case, the algebra is going to get messy because of all the terms, but you just need to persist. So this is the limit as h goes to 0. And f of x plus h would be x plus h minus 2 all over x plus h plus 4 minus f of x, which is x minus 2 divided by x plus 4, and is all divided by h. Just to save space on the screen here, I could write that then as just times 1 over h. Alright, so this becomes the limit as h goes to 0. Now we need a common denominator for those fractions there. So that would be x plus h plus 4 times x plus 4. That would be the common denominators, their product. And then the numerators I can just cross multiply here, so this ends up being x plus h minus 2 times x plus 4 minus x minus 2 times x plus h. X plus, have I done this correctly? That times that, and then this times that, x plus h plus 4. All right, that handles the part in the brackets, times 1 over h. Now, getting rid of those brackets by expanding them, we end up getting x squared plus 4x, and then hx plus 4h minus 2x minus 8, and then minus, now I'm going to multiply these things but then apply that negative to it as well. So x times x is x squared, that'll be negative, xh, that'll be negative xh, 4x, so that'll be minus 4x, negative 2x, so that negative will make it go positive, negative 2h, so that'll become positive 2h, and finally negative 8, that'll make it negative, will make it positive 8, and this is all over x plus h times x plus 4, and I can just bring this h underneath. Now, as promised before, anything that doesn't involve h's will go away. So here's x squared minus x squared, 4x and minus 4x, and negative 2x and positive 2x, and negative 8 and positive 8. So you notice all the terms without h's in them have disappeared. And so I could now write this as the limit as h goes to 0. So given that the only surviving terms all have h's in them, I could factor out an h. Well, I can put some stuff together here. So I've got hx here and then hx here. Oh, they actually disappeared. So this one and this one cancel. And so all I've got left is that 4h plus that 2h, which is 6h. So it's really just 6 left then. All over x plus h times x plus 4 times h. And now the h's cancel. And so we end up with the limit as h goes to 0 of 6 over x plus h times x plus 4 . And so now you can see that that ends up, as h goes to 0, this ends up just being 6 over, and if h is 0, that's just an x, so it's just x times oh, I forgot something here. Hold on, made a mistake. That was supposed to be, oh, I made a boo-boo here. This is supposed to be x plus h plus 4. Right, that was what's in the denominator before. So I have to fix this one as well. X plus h plus 4. And yet one more time. X plus h plus 4. But now as h goes to 0, this turns out to be x plus 4 on the bottom and another x plus 4, so that just ends up being x plus 4 squared. So that, remember what this represents. This is the slope of the tangent at any x. And so at x equal to 3, the slope would be 6 divided by 7 squared, which is 6/49. Now, up earlier here, we were talking about calculating the slope at x equal to 3, which I've done. If we're going to come up with the equation of that line, we need to know what the actual point was. So at x equal to 3, f of 3 would just be 3 minus 2, which is 1, over 3 plus 4, which is 7. So the point is 3 1/7, which is what that is right there. Okay, that's 3 1/7. You can check on your calculator. 1/7 is 0.143. So now using that point, because I have a preference for using fractions, the equation of the tangent would be y equals mx plus b. And the point of tangent C was 3 1/7. So we're going to substitute that and the slope into here. So 1/7 for the y. There's the x, there's the y, and there's the m. That comes into here. M is 6/49. X, which is 3, plus b. And when the dust settles, you end up getting b is equal to negative 11/49. And so the equation is y is equal to 6/49 x minus 11/49, which is the equation you see in my display here, 6/49 x minus 11/49 for the tangent. Hopefully this makes sense. I know the algebra is messy, but we need to learn how to do this from first principles. Later on, we'll see how we can make this a lot easier once we learn about derivatives. Okay, next. It says determine the points on this curve where the tangent is as specified. Now we've got a circle, of radius 4, that's x squared plus y squared equals 16. And we want to find out where's the tangent. Says determine the points on the curve where the tangent is as specified. In other words, where on that circle will the slope be the same as the slope of this line? Well, the first thing I suppose we need is what the slope of this line is. So negative 2y would be equal to negative 3x minus 7. And so y is just equal to 3 halves x plus 7 halves. So really this question boils down to is where's the slope of that tangent equal to 3 halves? But we need it to be tangent to, we need that line to be tangent to the curve. So that green line that I've drawn isn't tangent. And so if I were to draw a tangent, it might look something like this. That line there, oh, the green line is the line y equals 3 halves x plus 7 halves. And so we want the tangent line to be parallel to this. So that means it would have to run along something like this. And there's another place where that happens. So if I were to clone this line, it would happen over here as well. And so there are 2 points of tangency, one here and one here, where the tangent line is parallel to the green line that we were given. All right, so all we need to do is to come up with what the equation of the tangent is anywhere and set it equal to 3 halves and solve it. All right, so we start off by saying the slope of the tangent, whoops, I don't need it to be red. The slope of the tangent is equal to the limit as h goes to 0. All right, you see me do this enough times, I don't have to keep writing f of x plus h all the time. Now we need an expression for f of x, so we're going to just rewrite this equation here. So y squared would be 16 minus x squared, in which case y is just equal to the square root of 16 minus x squared. I'm not writing plus and minus. The plus would be the blue semicircle, and the minus root would be the bottom part of that semicircle, bottom part of that circle, or in other words, the red semicircle. Anyhow, let's not worry about the plus minus just yet. So the slope of the tangent would be the limit of f of x plus h, so that would be the root of 16 minus x plus h squared, minus f of x, so that would be the square root of 16 minus x squared, all over h. Now, I don't think I'm going to have enough room to do all of this, so I'm just going to take this further down and do it down here. There's a good spot. All right, so to solve this, you'll recall in all of the questions, at some point this h has to cancel something in the top. Right now we can't do that. And the only way to get an h to appear on the top would be by rationalizing the numerator. And so I'm going to multiply by the conjugate of that numerator, which is 16 minus x plus h squared, plus the square root of 16 minus x squared. Okay, and that would all be over the same thing, because we're really effectively just multiplying by 1. Okay, that's a 16 there. All right, so what's all that turn into? Well, it's not as bad as it may look. The bottom, don't bother trying to do anything with that, because we know that that h is going to go away eventually. So just leave this as the square root of 16 minus x plus h squared minus the square root, plus the square root of 16 minus x squared. So just don't do anything with the denominator. You'll recall that the top looks like a minus b times a plus b. which gives us a squared minus b squared. So I just have to, so this is like our a and this is like our b. And those are just the factors of difference of squares. And so this first part becomes a squared. Multiply, if I multiply this times that to get a squared, so that just removes that radical sign. So I end up with 16 minus x plus h squared, and then minus the b squared, which would remove that radical sign, but it becomes minus 16 plus x squared, right, when you apply that negative in. All right, let's just tidy this up and see where it heads. So the limit as h goes to 0 of 16, I'm going to square that binomial and apply that negative at the same time. So negative x squared minus 2xh minus h squared minus 16 plus x squared, and that's all over. I can just clone this. Maybe it'll be easier to, instead of having to write it out again, clone this. Whoops. Let's save some time. All right. And as promised before, all the terms that don't have h's in them go away. 16 minus 16. Negative x squared, positive x squared. And so we end up with the limit as h goes to 0. If this doesn't happen, by the way, that means you made a mistake higher up. Okay, this has to happen. And now if we factor the h out of the top, I end up getting minus 2x minus h all over this piece here, which I can clone again. And now the h's go away. And so we end up with the limit as h goes to 0 of negative 2x minus h all over, I'm glad this program has a cloning tool. Now what's going on? Oops. So we clone this whole thing. And now we're ready to take the limit. So as soon as you get it to this point, oh, that h is not there anymore. Let's erase this. Right, the h is cancelled there. So now as we take the limit as h goes to 0, you can see that the top will just end up being negative 2x, because h has gone to 0, all over. And if h goes to 0, we end up getting 16 minus x squared here, and another 16 minus x squared there. So we got two of these radicals now. 2 16 minus x squareds. And now the 2's cancel. And so now we just need to figure out when is that slope of tangent equal to 3/2. So that's, remember, this is the slope of the tangent anywhere. So now is when is negative x over root of 16 minus x squared equal to 3/2. Remember that the expression that we've just got here is the slope of the tangent anywhere. And so, but we want the ones that specifically are parallel to this green line. And we said that the green line slope is 3/2. So if we solve this equation, if we cross multiply, we end up getting negative 2x is equal to 3 times the square root of 16 minus x squared. And if we cross multiply, we've done that. And now if I square both sides, we end up getting 4x squared would be equal to 9 times the square root, we'll get rid of it. And if we now put everything together here, we end up with 4x squared minus the 9 times, that's negative 9x squared, but comes that side becomes positive 9x squared. And 9 times 16, 9 6 is a 54, carry 5, so 144. And so I end up with 13x squared is equal to 144, in which case x is equal to plus or minus the square root of 144 over 13. And this is approximately, if you work this out on your calculator, plus or minus 3.3. So if you look back at the graph back here, you can see that this one's happening at 3.3 right here. And here's the other one at negative 3.3. So it's just a matter, it said what are the points, so we need to figure out what these points are, that one and that one. Well, that's just a matter of putting that back into the equation, the circles equation, to figure out what the y is. Okay, so if you do that, you'll end up getting that using the circle equation, that y was equal to the square root of 16 minus x squared. And if you do that, f of 3.3 ends up being negative 2.2, and f of negative 3.3 ends up being positive 2.2. And so the points of tangency are, well, when x is 3.3, we got negative 2.2, and the other one is negative 3.3 and positive 2.2. Okay, so looking back at this graph, that kind of makes sense. One of them is y value is positive, and the other one y value is the negative. All right, hopefully you understood all that and got that by trying it on your own. Let's take a look at this next one. Now, this one is extremely messy, and well, you'll see why it's messy, because we've got a power function, we've got a linear function, we've got a reciprocal function, and by the time you calculate f of x plus h minus f of x all over h, the algebra is very messy. Okay, algebra is very messy. You're welcome to try it if you like. However, I'm leaving this for now because we're going to show you another way on how to do this, which makes it considerably easier to do. We're going to do one more question before we wrap up this lesson, and that is this one. I want to find out what's the equation of the line which is tangent to this curve but goes through this point specifically. Now, to understand why there are possibly multiple answers, let's just do a rough graph of what this thing looks like. 4 minus x squared, that's y-intercept is 4, so it's up here somewhere, and goes down like this. Right, the parabola opens downwards. And this point is 4. And the point 3, 4 would be about, well, let's say around here somewhere. 3, 4. And you'll notice that there are actually going to end up being two answers to this, because one of the tangent lines could be this one, because it goes through 3, 4 and is tangent to that parabola. And the other one could look like this. I'm just going to make these tangent lines look a little less like the axes here. So there's one of them, and here's the other one. Okay, so those are the two. We expect that there's going to be two answers, namely one that's tangent around here somewhere and one that's tangent down here somewhere. I don't know where this is. This is a very rough sketch, but I can tell that there's going to be two of them. So let's see if we can figure out where that is. Let's determine what the equation is of the line, those two tangent lines. So there's two of them. Now, we can do this in a number of ways. First of all, if we look at the slope of the tangent as equal to the limit as h goes to 0 of f of x plus h minus f of x all over h, minus f of x all over h. And this is another difficult one to do, and if you do this, you'll end up getting negative 2x. Now, at this point, we could proceed in two different ways. In the grade 12 curriculum, namely where this Calculus AP course is taught, in grade 12, we've got that the slope is negative 2x by using calculus methods and the limit methods. But in grade 9, certainly in Ontario, we would have learned that the slope is really just equal to, well, let's see what this would be. This point over here, whatever this x and y is, we don't know what that is. We know that when the first coordinate is x, the y is given by 4 minus x squared. Right? It's at either red of these red dots, I would write that. So now, using grade 9 methods and using this point right here, which is at 3, 4, and this red dot, the slope of that line would be 4 minus x squared, like y2, minus y1, so that would be the 4, all over x minus 3, right? So y2 minus y1 over x2 minus x1. And if we tidy this up, we end up getting the 4's cancel and end up getting negative x squared over x minus 3. Now, given that we've come up with the slope in two different ways, one way using calculus and one way using the slope formula, these two slopes must agree with each other. And so negative 2x must be equal to negative x squared over x minus 3. It's a matter of when does that happen? Well, if we cross multiply this, we get negative 2x squared plus 6x is equal to negative x squared. And then bringing everything to one side, I end up getting negative x squared becomes positive x squared minus that x squared, so that's minus x squared plus 6x is equal to 0. And if I factor out the negative x, I end up getting x minus 6 is equal to 0. And so now you see the two solutions. So either x is equal to 0 or x is equal to 6. So x equal to 0, that corresponds to this point. So that's at 0, 4. And this point ends up being, we saw x was equal to 6. So that's 6 and, well, I've drawn it on the axes, but I didn't really know where that point is. This point could be, much further down here somewhere. Can't really move it here. Hold on. Not that. See if I can grab. I need to grab this red dot here. So that would be down there somewhere. So this point is 6, and if I put 6 into that 4 minus x squared, we end up getting 4 minus 36, which is negative 32. Okay, this thing is not to scale, but these are the 2 points of tangency, and then it's just a matter of finding what the equation is of those lines. All right, so using 0, when x is equal to 0, we saw y would be 4, and then using when x is equal to 6, we said y was negative 32. The slope was given by negative 2x. Right? The slope for both cases would be negative 2x. So for this one, m would be 0. And for this one, m is equal to negative 2x, so the slope would be negative 12. If the slope is 0, then that means it's a horizontal line. And so one of the equations is going to be y is equal to 4. And the other one is y is equal to mx plus b. We stick this in for the m and stick that point in there. We end up getting negative 32 is equal to negative 12 times x, which is 6 plus b. And so b ends up being, this is negative 36, becomes positive 36, minus 32 would be 4. And so y is equal to negative 12x plus 4. So there are the two lines. Now, I haven't drawn this accurately here, but this second one, the one that's on the right here, its slope is negative 12, and its y-intercept is 4, interestingly enough, so it must also go through that red dot. How does that work, though? It doesn't seem reasonable. Something looks wrong here. Did I make a mistake? Y is equal to mx plus b. It's negative 12 times x. Oh, 12 times 6 is 72. Oh my goodness. That was a bad mistake. Let's fix that. Negative 72 goes to that side, positive 72. 72 minus 32 would be 40. That makes much more sense. So looking back at the graph at the top, the y-intercept for the second line must be very high up here at positive 40. All right, so that concludes this lesson. Thank you very much for watching rates of change in tangent lines, and we'll see you in the next video. Take care. Bye.